For thousands of years, there's been one undisputed king of strength. The material's so tough, its name literally means unbreakable, the diamond. It was the hardest thing we knew, the top of the mountain. But what happens when the unbreakable breaks? What you're about to see is the story of a material born not from perfect order, but from pure chaos. A substance that doesn't just challenge the king, it completely changes the game. You know, for as long as we've been building things, the diamond was the gold standard. Its perfect, orderly atoms created a structure so hard, it became the very tool we use to shape our world. For all intents and purposes, it was the king. But as they say, every king's reign eventually comes to an end.
Just look at this headline for a moment. From China Global Television Network. This is the story behind today's video. China unveils world's strongest ultra-high-strength carbon fiber. With that said, let's go straight to the intro.
And there it is. That right there, that's the bombshell. Dropped pretty quietly in a scientific journal, but it signals a monumental shift. I mean, think about that. A team in China didn't just find something as hard as a diamond. Nope, they created a kind of glass that can literally scratch the face of the old king. And here it is, the proof. What you're looking at is the hard evidence, right from their lab. That thin, undeniable line is a scratch mark carved into the surface of a natural diamond. The thing that made it, it's this yellowish see-through material they call AM3. It might look like just another piece of glass, but trust me, it's something else entirely. So yeah, this isn't just some weird thing they found in a lab. This is a huge deal. This is the dawn of a whole new era. The age of diamond supremacy is over. And frankly, what replaces it is a whole lot more interesting. So how on earth did this even happen? Well, this was no happy accident. This wasn't some lucky discovery. It was the result of a deliberate, focused mission by a team at Yanshan University. They specifically set out to create something that would conquer the one fatal flaw that all super hard crystals share. Okay, so here's the deal. Even a diamond has a secret weakness. It's something called anisotropic. That means it's got these cleavage planes. Think of it like the grain in a piece of wood. If you hit it just right along that grain, it shatters. So the mission was to create something isotropic, a material that's just as strong from every single direction, a material with literally no weak spots. And to pull that off, they had to do something kind of counterintuitive. They had to forget about creating a perfect, orderly crystal, and instead, they had to embrace pure chaos. They needed to figure out how to smash carbon atoms together into a structure that was totally disordered, but at the same time, unbelievably strong. So what's the recipe for making the impossible? Well, it all comes down to insane pressure and perfect timing. You start with these things called fullerenes, which are basically hollow soccer ball-shaped carbon molecules. Then you cook them at twice the heat of lava and squeeze them with 25 gigapascals. That's, well, it's like stacking 250,000 Earth atmospheres right on top of it. But here's the real secret sauce: the timing. They didn't just shock it, they slowly, carefully compressed and cooled it over 24 hours. This forced the atoms into a powerful, jumbled up amorphous state instead of a neat diamond pattern. And this image right here, this shows you exactly why this whole chaos thing works. On the left, you've got the diamond. Perfect, orderly, but predictable. See those straight lines? Those are the weak spots. But on the right, that's AMI3. It's a beautiful mess. Any force trying to break it just gets lost. It can't find a clean path to crack, so the energy just fizzles out. Okay, so mission accomplished, right? They made their super material. But what they ended up with, wow, it was even crazier than they hoped. AM3 isn't just equally strong in all directions. It turned out to be harder, tougher, and a whole lot smarter than the material it just dethroned. All right, let's just start with the main event. 113 gigapascals. That's its score on the standard hardness test. And let me be clear, most scientists thought a number like that was basically impossible for a glassy, disordered material. It just shouldn't exist. Now, to really get what 113 GPa means, check out this chart. You see AM3 way up there at the top? Look where the old champ natural diamond tops out, around 100. Other super hard materials are far below that. And stainless steel? You can barely even see the little sliver down at the bottom. This isn't just a small step up, it's a completely different league. But it gets even wilder. See, hardness is about not getting scratched. Toughness is about not shattering. And AM3 is ridiculously tough. We're talking 20 to 100 times tougher than most of the stuff we use for bulletproof windows today. It doesn't just resist a scratch, it resists being broken purely. But this is where AM3 pulls out its trump card. Think of a diamond as a big, dumb brute. Incredibly strong, sure, but it's an electrical insulator. It doesn't do anything else. AM3, on the other hand, it's a genius. It's also an amazing semiconductor. Like the silicon that powers all our electronics. It has this thing called a tunable bandgap, which is a fancy way of saying we can actually tell it how to conduct electricity. Having both these properties in one material, that's a total game changer. So the big question is, what can you actually do with the world's smartest, strongest glass? When you've got a material that's both a super fortress and a semiconductor, what does that unlock for us? Honestly, the possibilities here sound like they're pulled straight from a sci-fi movie. We're talking about a future where the very materials we use to build our world are pretty much indestructible. Okay, for energy, picture this. Solar panels out in the desert that get sandblasted 24/7 and don't even care. They just keep working. For defense, we're talking transparent armor that's orders of magnitude stronger than what we have now. And for us, in our everyday lives, this could be it, the end of the cracked phone screen, for real this time. And for the explorers out there, this is the stuff you make windows out of to go to the bottom of the ocean, or to land on another planet. So a breakthrough like this doesn't just happen in a bubble. And to really understand where AMV3 came from, you have to zoom out and look at the huge innovation ecosystem China has been building for years. The scientists who made AM3 weren't just working out of their garage. They were backed by China's National Science Foundation. And as you can see, this isn't a small operation. It's a massive innovation engine, pouring billions into research with a very specific goal: to solve the major needs of the country. This is strategic, it's deliberate, and what this does is it creates this incredible self-powering cycle. A breakthrough in one area, say clean energy, gives you the power you need to run the massive equipment that creates a new supermaterial like AM3. One success literally fuels the next. It's a closed loop of technological dominance. You don't have to take my word for it. The researchers themselves said it best in their paper. They call it an excellent candidate for the most demanding of practical applications. That's not just scientific jargon. That's them saying we know what we've got and we're ready to use it. So what does all of this really mean? It means we've turned a massive corner in human history. We've left the age of just finding cool materials in nature. AM3 is proof that we are now officially in the age of designing materials, building them atom by atom to do exactly what we want. And that just leaves us with one final mind-bending question. If we can now bend chaos to our will to make glass that can kill a diamond, what comes next? What's the next impossible thing we're going to build? Thanks so much for watching. The 1,000-year reign of the unbreakable diamond is officially over, and the age of materials built from chaos, well, it's just getting started.